Hi students, welcome to this video session. I remain Samuel Chukwu Emeka, aka Samdom for Peace. In this video session, we shall discuss the first part of your Test 2 study guide. Test 2 study guide, part 1. Please, before you view this video session, it is highly recommended that you look at the prerequisites. These are the prerequisite videos. And it is also recommended that you view this video with the notes. So as you are viewing the video, it is recommended you also pull up the notes to go with the videos. So in this session, we shall determine the probability of an event. Then we shall determine the probabilities of independent events, dependent events, mutually exclusive events, and complementary events. Question 1. 11 of the 50 laptops sold in a certain store on Black Friday were defective. Find the probability of randomly selecting a non-defective laptop. So you will notice that in the questions on probability, we talk about randomly selecting. It has to be a random selection. So we have 11 defective ones, but we are being asked to find the probability of selecting a non-defective one. So how many non-defective ones do we have? We now is 50 laptops, 11 are defective. That shows that 39 are non-defective. So the probability of selecting a non-defective laptop will be the cardinality, how many non-defective laptops we have, divided by the total number of laptops we have, the cardinality of the sample space. That gives you 39 out of 50, which is 0.78. Question 2. A modified roulette wheel has 44 slots. One slot is 0, another slot is 0, 0, and the other slots are numbered 1 through 42 respectively. In a roulette, 0 and 0, 0 are neither odd nor even. Timothy went to the casino and placed a bet that the outcome is an odd number. What is his probability of winning? So we know that 0 and 0, 0 are not odd, they are not even. And we have only numbers now, numbered 1 through 42. So between 1 through 42, we have 21 odd numbers and 21 even numbers. But we still notice that the cardinality of the sample space is 44. We have to include that. So the probability of selecting an odd number, this should be probability. I will change it, okay? This will be probability of selecting an odd number. I'm going to change it after this video. So that will give you 21 out of 44. Now, what are his odds against winning? So we have the formula here that odds against an event is equal to the cardinality of the unfavorable outcomes is to cardinality of favorable outcomes. How many unfavorable outcomes we have? Okay, the ratio of the number of unfavorable outcomes to the number of favorable outcomes. So in this case, Timothy wants an odd number, so which means odd numbers are the favorable outcomes. So the odds against him winning an odd number will be the unfavorable outcomes are the even numbers, then 0 and 0, 0. He doesn't want those numbers. Okay, he wants odd numbers, which are now the favorable outcomes. So we now have that the unfavorable outcomes, which are the even numbers 0 and 0, 0. That gives us 23 numbers altogether. And of course, we have 21 odd numbers. So the odds against him winning an odd number is 23:21. Okay, the ratio of 23 to 21. The C part. This question has kids. It has children. So the C part, the payoff odds for an odd number are 1:1. How much profit would Timothy make if he bets $16 and wins? So this is the formula for payoff odds against an event. So this is the ratio of the net profit to the amount bet. And we see that the payoff odds is 1:1, which is equal to, he bets $16. So how much profit would he make? So the net profit is to 16. So you express this as a fraction, and when you do the cross product, you find that the net profit will be $16. D. If Timothy convinces the casino to change his payoff odds to be the same as the actual odds against winning, how much profit would he make on the $16 bet? So in this case, we see that the odds against winning was 23:21. That was what we got here, 23:21. So instead of 1:1, he wants the casino to now take this as the payoff odds. Okay, so instead of 1:1, he wants 23:21. Okay, so in this case, the new payoff odds, the new net profit now, he still bet his $16, will now be the odds against winning an odd number, which is 23:21. And when you do cross products, I can show you here. Let me pull up my notebook. Let me see a new section. Let's say test 2, study guide, part 1. Okay, so what would be his new net profit? He wants he still wants to bet the $16, and rather than the payoff odds being 1:1, he convinces the casino to now change it to his odds against winning an odd number. So that means that the new net profit, I'm going to get this draw. Let me get this. So the new net profit, okay, let's call it NP, the new net profit. Oh, this is too thick. It is too thick. Let me get this. So new net profit over $16 will be 23:21. And if you still remember your cross product, your butterfly method, do you still remember that? Your butterfly method. So this means that 21 times the net profit is equal to 16 times 23. So you divide both sides by 21. You now see that the new net profit will be 16 times 23 divided by 21. Okay? And when you do that, that gives you $17.52. Question 3. A group of airline passengers responded to a question about their favorite seat on a plane. 501 passengers chose the window seat, 10 chose the middle seat, and 297 passengers chose the aisle seat. This question has children also. A. Determine the probability that a passenger prefers the middle seat. Round your answer to 3 decimal places as needed. We talked about as needed before. When they ask you to round something as needed, it means you could round to, if you get your answer to more than 3 decimal places, you round it to 3 decimal places. If your answer is not up to 3 decimal places, you can just leave it as that. So that is what as needed means. If your answer is not up to 3 decimal places, that's fine. Leave it like that. But if your answer is 3 decimal places, that's fine too. But if it's more than 3 decimal places, then you round it to 3 decimal places. So we first of all get the sample space, cardinality of the sample space. When you add up all the passengers, it gives you 808 passengers. So to find the probability that a passenger will choose a middle seat would be 10 out of 808. And that gives you 0.012. B. Is it unlikely for a passenger to prefer the middle seat? And then why? Well, if you look at this probability with the 5% rule, this probability is very unlikely because this is less than 0.05. So passengers don't like the middle seat. And why do they? They don't like the middle seat. Most prefer the window. I prefer the window too. I don't like middle seat. Now, why? When the person in the middle seat, the person sits in between 2 other passengers. The person lacks the access to watching the sky, Also lacks access to the aisle. You have to cross one person before you get on the aisle. There's no outside view of the sky, among others. Question 4. A family that resides in the city of Truth or Consequences, New Mexico. There's a city like this. I would like to go to this city. I just like the name. City of Truth or Consequences in New Mexico. Speak the truth or face the consequences. Okay, the family are planning to have 4 children. Assume that boys and girls are equally likely. So, with boys and girls being equally likely, that means that the probability of having a boy will be the same thing as the probability of having a girl. And that would be 1/2. Okay? So, let our B be boy and let the G be girl. The A part says, determine the probability that the couple will have at least 1 boy. So with the at least 1 boy, it means 1 boy or more. It could be out of 4 children. They could have 1 boy or 2 boys. They could have 1 boy and 3 girls, or 2 boys and 2 girls, or 3 boys and 1 girl, or all 4 boys. So there are 2 ways to solve this. We shall discuss those 2 ways. The way I prefer is the easy one. At least 1 boy means greater than or equal to 1 boy. So the complement, remember in class we talked about a complement of this at least. So the complement of at least 1 boy means probability of having all girls. The event of having at least 1 boy, the complement of that event is the event of having no boy or all girls. I repeat, the complement of the event of having at least a boy is the event of having no boy, and that no boy means all girls. So with the complementary rule, with the complementary rule for probability, the probability of having one boy plus the probability of having all girls will be 1. That case, the probability of having at least one boy, okay, the probability of having at least one boy plus the probability of having all girls gives you 1. So in that case, the probability of having at least one boy will be 1 minus probability of having all girls. So see what I'm saying here. Look at what I'm saying here. The probability of having greater than or equal to one boy plus the probability of having all girls, G. Because this is complementary event, will give you 1. All girls will give you 1. So if you want to find the probability of having at least one boy, that will give you 1 minus the probability of having all girls. And of course, the probability of having a girl is 1/2. So from a multiplication law, it will be 1/2 times 1/2 times 1/2 times 1/2, which is a 1 minus 1 out of 16, and that gives you 15 out of 16. That is the method I like. That is less work. But some folks like, okay, I am a visual person, Some folks are kind of visual, or some folks want you to kind of break it down real good for them. Okay, in that case, you might need the second method. So, out of 4 children, in this case, the first child, the second child, the third child, the fourth child, these are important to us. So let us list all the possibilities, okay? Remember, out of 4 children, we want at least one boy. So we can have 1 boy and 3 girls. We can have 2 boys, 2 girls. We can have 3 boys, 1 girl. Or we can have all 4 boys. Okay, now, you have to now know the order of listing, okay? Like, in the case of 1 boy and 3 girls, the first one can be a boy, second girl, third girl, fourth girl, or first girl, second boy, third girl, fourth girl. So that is the thing now. You have to list it. You gotta list it because each one, the order is important to us. Okay, the order is important to us. So you could have 4 boys or 3 boys and a girl. In this case, first one is boy, second boy, third boy, fourth girl. Here, first boy, second boy, third is girl, and fourth is boy. So you list all of it, and you will get 15 out of 16. Each one has 1/16 chance of occurring. So when you count all of them, you get 15 possibilities. You get 15 out of 16. Which method do you prefer? First or second? I prefer the first, but if you really want to explain it in details, then you would use the second. Question 5. The table below shows the results of 928 pedestrian deaths caused by accidents. So, these are intoxicated pedestrians, 52 plus 260. And these are non-intoxicated pedestrians, 56 plus 560. These are intoxicated drivers, 52 plus 56. And these are non-intoxicated drivers, 260 plus 560. So even though we were told that from the question that 928 pedestrian deaths, so the cardinality of the sample space is 928, we still want to confirm, okay, by adding up everything. Okay, add up everything. 52 plus 56 plus 260 plus 560. That gives you 928. Now, the question is, if one of the pedestrian deaths is randomly selected, what is the probability that the pedestrian was intoxicated or the driver was intoxicated? So we look at the pedestrians that are intoxicated, 52 plus 260, we keep that. We look at the drivers that are intoxicated, 52 plus 56, we keep that. Then we shall use the addition rule. Addition rule means that the A union B is probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. So in this case, they asked us all, what is the probability that the pedestrian was intoxicated or union. When you see or is union. Then when you see and it is intersect. Okay, you did sets. If you see union, this is union and this intersect. Okay, this is union. I've got to fix it. I wrote this one like you. Okay, I will fix it. Okay, it's union, just like this. It is not you. No, it is union. So they are asking us for all. We also need to find and, because we have this in the formula. The probability that the driver is intoxicated pedestrian or intoxicated driver, IP or ID, is the probability of selecting an intoxicated pedestrian plus the probability of selecting an intoxicated driver minus the probability of selecting an intoxicated pedestrian and an intoxicated driver. What are the intoxicated pedestrians and drivers? Is right here, 52, right here. 52 are both intoxicated because this is for pedestrian. The column is for pedestrian and the rows are for driver. Okay, so when you plug in the formula, you have that of intoxicated pedestrians is 312. So 312 out of 928 plus that of intoxicated drivers is 108. You do 108 out of 928. We found those here. Okay, the cardinality. How many intoxicated pedestrians do we have? We have 312. How many intoxicated drivers do we have? We have 108. Okay, then minus how many intoxicated pedestrians and drivers do we have? We have 52 of those right here. This 52 right here. So when you do that, you find out that this is a 368 divided by 928, and that is 0.397. I will color this in red. If you notice, my answers are colored in red. You know, that shows is the answer. So I gotta color this in red too. All right, question 6. The table shows the results of people within several age groups who responded and who refused to respond to a particular survey. So we have this table. These are the age groups right here. And these are the numbers of those who responded, okay, within these age groups. And these are the numbers of those who refused to respond within these age groups. A. Determine the probability that a randomly selected person refused to respond. So first of all, let's find everybody. What is the entire people that we are giving the survey? What is the cardinality of the sample space? We have it as 1231. Then we now find the cardinality of those who refuse to respond, and they are 194. So the probability of selecting a random person who The probability of randomly selecting a person who refused to respond is 194 out of 1231. And that gives you 0.158 when rounded to 3 decimal places. Okay, you round it to, the question says round to 3 decimal places. So when you do that, it is 0.158. I will also color this. Then the second question under that question, I think that is question 6. Yeah. Is this a problem? Like this probability, does it shows that refusals are a problem for pollsters? So this is actually, this is like 15.8%. This is actually significant when dealing with polls. When you give surveys and 15.8% did not respond, they refused to respond, those are the people that might be very mad at you. Okay, so that causes a problem. Or those are the people that might not want to respond, and those might be the people that are angry or something, but they are part of the population and they just refuse to respond. So you are lacking the results from those part of the population. So the population of people, you don't have a true representative of the population. If you have a section of people who refuse to respond to surveys, it's just like the surveys that is given at the end of the semester when you are asked to evaluate the instructor. So you notice that those who respond are those who probably like the instructor very well, or those who are really, really mad at the instructor. So those are those who respond. And then the folks, the folks who are kind of neutral, they don't respond. Especially when you don't give them 5 points or 10 points. Why should you give somebody points just to respond to a survey? I mean, come on. I don't agree with that. But anyway, if you don't have, if you have up to 15% of people refusing to respond, you are missing a representative of the population, and that is a problem. That calls for a problem. Okay. Question 7. A drug testing company tested several job applicants for marijuana. Okay. 146 applicants tested positive, but among them were 26 false positive results. 160 applicants tested negative, but among them were 3 false negative results. Represent this information in a table. So first of all, what do we mean by false positive? And what do we mean by false negative? So false positive is a situation whereby the applicant does not use marijuana, but the test indicates that he is using it. So he or she tested positive for it. Okay, the applicant tested positive for it when in fact that applicant does not use marijuana. That is like sentencing an innocent man, right? Somebody doesn't commit a crime and you sentence him for a crime he doesn't commit. Okay, a false negative means that the applicant actually used marijuana but tested negative for it. That's a false negative. Okay, so this case is like letting a guilty man go free. Okay, so I'm trying to talk about this now so that you can make reference to it when we discuss type 1 errors and type 2 errors. You can kind of see the connection to it. Yeah. So which among these is very, very serious? That is like sentencing an innocent man. It is better to let a guilty man go free than to sentence an innocent man. Much better, much more better. Okay? So false positive is a very grave scenario. Very grave scenario. False positive. So now, these applicants, we have 146 applicants came out positive, but among them, 26 were false positive. So that means that actually, which ones were true positive? True positive. You do 146 minus 26, and that gives us 120. You have to find true positive, false positive, which was given already, then true negative, and then false negative, which was given already. Also, 160 applicants tested negative, but among them were 3 false negative. So the true negative will be 160 minus 3, which gives you 157 applicants. So we will just denote this, I denoted it as P, TP, FP, N, TN, and FN. Okay? So when you represent it in a table, it looks like this. True positive is 120. False positive is 26, which was given to us. False negative is 3, which was given. Then you subtract it from 160 to get the true negative. Okay, this is question A. Now, question B. How many job applicants were tested? It's just 146 that tested positive and 160 that tested negative. So we have 306 applicants. C. How many applicants did not use marijuana? So in this case, did not use marijuana, which means true negative, okay? True negative, those who tested negative didn't use it, true, okay? And false positive, those who did not use it but tested positive for it. So these are the ones that are no marijuana. I called it NM, no marijuana. Okay, I called it NM. So this is the true negative plus false positive. And that gives you 157 plus 26, which gives you 183 applicants. Now, how many applicants used marijuana? In this case, these are those that tested it positive, true positive, and false negative. Okay? Because false negative means that they actually used it, but they tested negative to it. So, and true positive means they actually used it and actually tested positive to it. Okay, true positive means they used it, they tested positive to it. True negative means they did not use it and they did not test positive to it, which means they tested negative to it. That is true negative. False positive means they did not use it, but they tested positive to it. And then false negative means that they used it, but they tested negative to it. So the actual people that used it will be the true positive and the false negative. That gives you 123 applicants. E. Determine the probability that a randomly selected applicant did not use marijuana. So we still use the formula. How many people did not use it, which is 183, divided by 306. Okay. F. Determine the probability that a randomly selected applicant used it. So in this case, 123 used it. We divide it by 306, we get 0.402. And if you add up this, if you add 0.402 and 0.598, it gives you 1. Okay, gives you 1. So the probability of those that used it plus the probability of those that did not use it will give you 1. And that is what we call what? What do we call it? Complementary rule. Complementary rule. If you add this and this, gives you 1. G. Determine the probability that a randomly selected applicant tested negative or addition rule or did not use marijuana. Okay, so in this case you use the addition rule the union, the probability of those that tested negative, and all no marijuana. So that is probability of those that tested negative plus probability of those that did not use it minus probability of those that tested negative and did not use it. So if you look at this now, before you look at what I did, if they asked you this, what are the people who, what will you call these people? Those who tested negative and did not use it. They are the true negative, actually. Okay? They are the true negative. They tested negative and they did not use it. True negative, and no marijuana. So those are the true negative. Okay? So, and they are 157. If you look at this, yeah, they are the true negative, 157. So that is the intersection. Those that tested negative and did not use it, they are the true negative. Then those that tested negative is 160 over this. And then we have found this earlier on. We found probability of no marijuana was 183 over 306. So when you do that, you get, if you add and subtract that, you get 186 over 306, and that gives you 0.608 when you round it to 3 decimal places. Question H. Determine the probability that a randomly selected applicant had a false positive or a false negative result. So in this case, we are still going to use the addition rule because of all false positive or false negative result. So we write our addition rule as usual. Now, do we have a case whereby we have both false positive and false negative? Intersection of this. Is it possible to have a false positive and a false negative at the same time? Is it possible to randomly select to find a person who tested, false positive and false negative at the same time? And the answer is no. So these two events are what we call disjoint events or mutually exclusive events. Okay, they cannot occur simultaneously. They cannot occur at the same time. So the cardinality is 0. Now the event is a disjoint. They are disjoint events. So the set is a null set, but the cardinality is 0. So when we do that, we have a 26 plus 3 minus 0 divided by 306. And that gives us 0.095. Question I. Determine the error rate of the test results. And what does the results suggest about the accuracy of the test? So you have an error rate that is 9.5%. That is too much. So that tells you that this test is not accurate. It's not accurate at all. Okay? Because of the error rate. The last but not the least for this part 1, we have question 8. The table shows the blood group and rhesus factor of 224 patients. So we have the blood group O, A, B, and AB, and we have the rhesus factor positive and rhesus factor negative. These columns are the blood groups, while the rows are the rhesus factors. Let's check, like I mentioned earlier, even though you were given the cardinality of the sample space, which is 224 patients, it is still important that you verify that. Okay, so when you add up everything, you can either add it by rows or by columns. You will still get 224 patients. Okay, question A. What is the probability that two randomly selected patients selected with replacement are both group AB and rhesus positive. So this is with replacement. So that means now you have 224 patients at a clinic. You close your eyes and you just pick one patient. What is the probability that the patient you picked has blood group AB and has rhesus positive? So you count how many people are in that category. We have 9 people, 9 patients that have both blood group AB and rhesus positive. So that will be, and now you selected the first person, so the probability there will be 9 out of 224. Then you now ask the person to get back into the room. Okay, so you replace it's with replacement. You ask that person, okay, go back and join the rest. You closed your eyes and you selected another person in that same category. So that will still be 9 out of 224. These are independent events. So you just multiply it, okay? So when you do that, you have 0.0016. Now, the second question deals with without replacement. Without replacement, okay, what is the probability that the 2 patients you select are both blood group AB and rhesus positive, but without replacement? Okay, you make the selection without replacement. So you close your eyes, you select the first patient. That is 9 out of 224. Okay, well, you now ask that person to go home. So let's say you discharge that patient. You did not replace that patient. Well, when you have done that, just know that the category, it used to be 9, but you now ask that person to go back. So the remaining people in that category will be 8 people. Also, the cardinality, the total number of patients that were 224, will now be short by 1, short of 1. So they now be 223. So this is without replacement, and that is dependent events. We discussed this in class. So the probability of making that second selection, the probability of making a second selection, because you did not replace the first, will now be 8 out of 223. And when you do that, you now have 0.0014. Okay, these are dependent events. The 2 events are dependent events because the probability of the second one is directly affected by the probability of the first one. You didn't replace that first patient. Okay, so we shall stop here for tonight. Please watch out for other parts based on still test 2. Okay, these are the references. Thank you so much for listening, and you have a good evening.